Hi everyone, I'm the instructor for Chem232, and the purpose of making these few videos here is to make it easy for you when you study OChem. Normally OChem is a very challenging topic, and the purpose again with these videos is to make it a little bit easier for you. So the first video we're going to talk about how to draw simple molecules and look at them in various views. So when you're looking at organic molecules, what you can do with any type of atom, for instance a carbon atom, you have that always has to be 4 bonds. So if you keep that in mind and look at nitrogen also, at the same time that you have 3 bonds and an electron pair, you can do the same thing for oxygen. So drawing oxygen atoms connected to various atoms, for instance hydrogens, makes these molecules neutral. It doesn't have to be hydrogens, but keep that in mind when we draw the structure for these. Same thing with oxygen here as it is for nitrogen, that you need to also consider the 3 electron pairs that you have on these atoms in order to have a field octet, and that's the requirement. So with that in mind, and because carbon can bind molecules in various ways, organic chemistry is devoted to carbon. Carbon, the position of that atom, or the element in the middle of the periodic table. So you can draw basically organic molecules in an infinite number of ways. So what we're going to do is to draw some molecules, and I'll show you various ways to do this. So we're going to start out with drawing a molecule in what we call a condensed structure. So if you have a condensed structure, for instance, something that looks like this, CH3, you have an NH, CH2, CH, CH3. And of course, this looks very complicated as is. And I'm going to show you here then, by simply drawing it in a different light, you will then identify the electrons in the molecule. Because what you're dealing with when you're talking about organic chemistry, and particularly dealing with organic reactions, is not specifically the atoms, but instead the electrons on atoms and between atoms that is responsible for organic reactions. So this is again a condensed formula, and looking at that molecule this way is actually very hard. So you see molecules like this, one should try to translate these molecules to something called Lewis structures. Lewis structure. So if you draw a Lewis structure for this same molecule, what you then need to do here is to translate the CH3 groups, in this case connected to your nitrogen. So what you then have here is an CH3 indicated like this. And if you continue over here, then what you then have is your CH2, which is this atom up here, and then here now you have a CH, and connected to that CH you have a CH3 like this. And you see here now that we indicate the bonds between the atoms, and each bond, of course, since you're dealing with covalent bonds, have a field octet. So what you then have here then, that CH2 will then be this one, and then you have a CH2 on the end here, and then you have an OH. Here it looks like we have indicated all of the electrons necessary, because that is what Lewis structure is all about. You need to include all of the electrons in the molecule. You see here that's an hydrogen missing here. I'm going to include that. But then if you look carefully now here, this is actually an incomplete Lewis structure. And the reason is that you have these 3 electron pairs missing on the hydro atoms, in this case the oxygen and your nitrogen. That is a good way to actually start understanding organic chemistry. So you're simply looking at the molecules like this rather than looking at the condensed structure, I should say. An even simpler way to draw this molecule would be what we call the line angle structure. The line angle structure. The line angle structure. So what we're going to do is translate this molecule into line angle structure. And what that would be then is something that looks like this. And then you have your CH2 group, which is this point here, and then you have a CH, and then a branching of this CH3, and then you have CH2, CH2, and OH over here. So you see it is much faster to draw the molecule. And then again, don't forget here now that you have 3 electron pairs on the heteroatoms here and here. So that's a very simple way to draw molecules. So this line here basically indicates a connection to an CH3 group. So in the line angle structure, you can clearly see that we don't point out the carbon-hydrogen bonds, but they are there. So please get used to these Lewis structures initially, indicating all of the carbon-hydrogen bonds, but then ultimately when you get a feeling for this, then you can translate this drawing to this structure here. Just so that we are on the same page, for instance, if you look at this carbon here, what you of course have, right, but we haven't indicated that, are 2 hydrogens sitting here. One is pointing towards you, which is this one, and then this one here pointing behind the glass. So that would be an sp3 hybridization, for instance. So you see in the line angle structure, we actually don't include the hydrogens originally, but you can do it, and you should probably practice that so that you get used to that. All of these kinks on the carbon chain, that's where you have hydrogens. For instance, you have another hydrogen here, but it's not indicated. So that hydrogen there will be, this one here will be this one located here in the Lewis structure.